All right, think of us as cosmic detectives for today, because we're about to reopen a case that pretty much everyone thought was closed for good. The age of the universe. Yeah, we're going deep on one of the most fundamental numbers in all of science.
You know, for most of our lives, if you asked a scientist, hey, how old is everything? They'd give you a pretty solid answer. And that answer, that one number, it wasn't just a fun fact. It was the bedrock of cosmology. It's literally the first sentence in the story of our universe. And here it is, 13.8 billion years. Now, this wasn't some back-of-the-napkin calculation. We're talking about major players like NASA and the European Space Agency confirming this number back in 2013 with insane precision. For all intents and purposes, the case was closed. But, you know, every good cold case has that one piece of evidence that just doesn't fit.
So, what happens when the clues just don't add up? What if you find something that just shouldn't exist? Because that's pretty much what's happened, and it's threatening to unravel our entire understanding of cosmic history.
Okay, meet Exhibit A. This is a star in our own backyard, cosmically speaking, nicknamed Methuselah. Now, the wild thing is, scientists estimate this star is somewhere between 14 and, get this, 16 billion years old. So, how in the world can a single star be older than the entire universe? Yeah, something is very, very wrong here.
So, to really get why this is such a big deal, we got to look at how we got that 13.8 billion year number in the first place. This wasn't just a shot in the dark. It came from two completely different ways of measuring, and for years they both pointed to the exact same age.
So, how exactly do you tell the universe's age? Well, we have two main tools in our detective kit. The first one is kind of like hitting rewind on the entire cosmos. You take the expansion of the universe, that big outward push, and you balance it against the pull of gravity from all the stuff in the universe, and you just run the clock backwards until everything converges. The second method, think of it like a cosmic speed gun. We point it at distant galaxies, measure how fast they're speeding away from us today, and then we calculate how long it must have taken them to get where they are.
And what's really fascinating is how that speed gun method has evolved. You know, back in the day, Edwin Hubble's first attempt gave an age of only 2 billion years, which is younger than our own planet. Obviously, that wasn't right, but as our technology got better and better, that number got dialed in, landing right around that 13 to 14 billion year mark. So both methods were agreeing, the science felt settled. And then, the James Webb Space Telescope happened.
And this, right here, is where our cold case suddenly gets red hot. Because the James Webb Space Telescope, the JWST, started sending back pictures from the edge of time, and what it saw just does not compute. These things simply shouldn't exist if the universe is only 13.8 billion years old.
So let's look at the evidence log. JWST spots at least 6 galaxies, so far away that we're seeing them as they were just 500 million years after the Big Bang. But here's the kicker. They're not baby galaxies. They are absolute monsters, some as massive as 1 trillion suns. And, this is the really important part, they're filled with old, red, mature stars. And this is the heart of the contradiction. The theory said we should find these small, messy, toddler galaxies full of bright blue, brand new stars. Instead, JWST found what looked like fully grown, middle-aged galaxies that seem like they've been evolving for billions of years already. It's like finding a picture of a 40-year-old man, but the photo was supposedly taken 2 minutes after he was born. It makes absolutely no sense.
Okay, so when the evidence breaks the theory, you need a new theory. And this is where our story's new detective comes in, Dr. Rajendra Gupta. He looked at this impossible puzzle and thought, maybe the answer isn't something new, maybe it's in a couple of old ideas that everyone else forgot about.
Okay, so his first clue comes from an old theory called tired light. The idea is that as light travels for billions of years, it gets tired. It loses a little energy, which stretches its wavelength and makes it look redder. Now, for decades, this idea was on the shelf because it predicted that really distant stuff should look blurry, and it doesn't. But Gupta thought, what if it's not the only reason light redshifts? What if it's just one piece of the puzzle?
The second forgotten theory is a mouthful, covariant coupling constants. But the idea is pretty wild. It suggests that the fundamental laws of physics, things we assume are totally constant, like the speed of light or the force of gravity, might not be so constant after all. What if they've actually changed over cosmic time?
So what Dr. Gupta did was brilliant. He basically took our standard model of the universe and bolted on these two old ideas, a little bit of tired light and a little bit of changing physical constants. He created this new hybrid model, and then he ran the jaw-dropping JWST data through it, and the result was a perfect fit.
And this is the smoking gun, right here. If you try to make the standard model fit with what JWST is seeing in those early galaxies, it just doesn't work. The data doesn't line up. But Gupta's new model, it explains the observations beautifully. It creates a universe where those huge, ancient-looking galaxies have plenty of time to form.
So, when you recalibrate the cosmic clock using this new model, you don't get 13.8 billion years, you get 26.7 billion years, almost twice as old. And suddenly all the pieces fall into place. The Methuselah star isn't an anomaly anymore. Those impossible galaxies are, well, they're perfectly possible. Case closed, right? Well, not so fast.
Because in science, an extraordinary claim needs extraordinary proof. And the rest of the scientific community isn't exactly jumping to throw decades of research out the window. There are some really big questions and counterarguments that we have to look at.
So this is where the debate stands. You've got Dr. Gupta saying, look, the evidence is clear, the universe has to be way older. And then you have the rest of the field pushing back saying, hold on, maybe there are other explanations for what we're seeing. Or maybe we're not even seeing what we think we're seeing.
Okay, so the first major objection is all about assumptions. Astrophysicist Dr. Maddow makes a great point. We're assuming stars back then behaved like stars do today. But what if they didn't? The early universe was a crazy place. Maybe the first stars were absolute behemoths that burned through their fuel incredibly fast. So what looks old and red might just be a star that lived fast, died young, and left a good-looking corpse.
And the second counter-argument is maybe even bigger. It basically questions the evidence itself. Astrophysicist Tamara Davis has suggested, hey, what if the problem isn't our theories? What if it's our shiny new telescope? The JWST is an incredible instrument, but it's new. It's possible it just needs to be recalibrated, and that all of this impossible data is just a glitch.
So what does that leave our investigation? Well, the case is wide open. We've got the official story, we've got a star that shouldn't exist, and we have bombshell evidence from our best new detective on the scene, the JWST. We have a radical new theory that ties it all together neatly, but it also has some major holes poked in it by the experts. The debate is raging, and this investigation is far from over. What's at stake? Oh, just our entire history of the cosmos. The question now is, what does the next piece of evidence reveal?